So in this lesson, we are simply going to learn how to solve for x in root equations. So let's say they give you the equation. They say you have the square root of 2x plus 1, which is set equal to x minus 1. Well, the first thing that we need to do here is to destroy the square root. And the best way of destroying the square root is by squaring on both sides. So now the square root and the square will cancel out. So now we are left with 2x plus 1. And on the right-hand side, we actually have x minus 1, which is all squared. But of course, we understand that x minus 1 is repeated twice, in which case we have to use the FOIL method. And after successfully using the FOIL method, we simply get x squared minus 2x plus 1. Then here we are simply going to take this 2x plus 1 to the right-hand side because we want to collect the like terms, right? So now we are left with 0 on the left-hand side, and x squared goes alone. This 2x becomes negative when it gets to the right, and negative 2x minus 2x, we get 4x. And of course, 1 minus 1 will just be 0. And I have a very big confession to make. I don't really appreciate it when a number is on the left-hand side and an expression in terms of x is on the right-hand side. So I'm simply going to rewrite this in the way that I'm comfortable with. So now this is what I'm having. Then here we simply take x out as the highest common factor. So now we are left with x minus 4, and we set this equal to 0. So then this means x equals 0 or x equals 4. But of course, you could have said x minus 4 equals 0 and then say, therefore, x equals 4. Well, that's perfectly fine. But this is the only time you will see me saying this. I won't really do this in all problems that follow, all right? Because it's not really necessary for you to do that. But yeah, if you want to do it, it's perfectly fine. And this is the most important thing. Every time when you are dealing with root equations, you always have to verify, always test if the two values of x that you obtained actually work. Check if the left-hand side is equal to the right-hand side, all right? Okay, now let's take this x equals 0 and we go to the original equation. Always go to the original equation. And the original equation is the one in black. Just forget about those red parts, all right? Well, 2 by 0, that's 0. 0 plus 1, that is 1. The square root of 1, that's 1. But then on the right-hand side, 0 minus 1, that's negative 1. And the left-hand side is not equal to the right-hand side. So we have to cancel this 0 out. That's how you cancel it out. You say x cannot, that's the meaning of that symbol, cannot be equal to 0. Now, what about x equals 4? Well, 2 by 4, that's 8. 8 plus 1, it's 9. Square root of 9 is 3. 4 minus 1, that is 3. So the left-hand side is indeed equal to the right-hand side. So x equals 4 is your only solution. Now the question is, where are the marks? For squaring on both sides, you get a mark. For writing this equation in standard form, you get a mark. For factorizing, you get a mark. And for writing your two solutions with selection, What do I mean with selection? I mean you choose x equals 4 only by canceling the one that doesn't work. So you get a mark for that as well. But sometimes they can choose not to give you a mark on your factors and give you a mark for those two values of x with selection. So it will simply depend. Right. So that was it for this question. This was the easiest case we can get for today's lesson. So then let's look at the next one, which is considerably challenging compared to the one that we just did. Otherwise, what's the point? Well, it's pointless. And I hope you know that the word pointless means the point is there, just that it's less. No, I'm kidding. So let's proceed. So let's say once again, they ask you to please solve for x in this case. Well, here they say you have the square root of negative 2x plus 4. And then you say minus x here. And everything is equal to 2, all right? Well, the first thing that we need to do here is to take this x to the right-hand side, because remember, we want to destroy the square root. And in order to destroy the square root, we have to square on both sides. And it's actually easier to square on both sides if we don't have this term, which is the x there. So now we are simply going to have the square root of negative 2x plus 4. And this is set equal to x plus 2 on the right-hand side, all right? Okay. And I really have to warn you. I see that some of you, maybe when you write, you just do something like this, and then maybe you say negative 2x plus 4. What is this? Please don't be lazy. Use a full square root, not even something like this, because this thing is completely different to this one. Please respect mathematics and do things the right way. But remember what I told you. You don't need to stress which one is the right way. If you do exactly as I do and exactly as I tell you, then you're doing things the right way. All right? So just worry about doing as I do. And of course, your happiness will be complete. So, well, this step normally has a mark. They call it isolating the root. So it does have a mark if maybe it's a 5-mark question, all right? So now it's time for us to square on both sides. Well, this is what we are simply going to have. So now the square root and the square will cancel out. On the right-hand side, we have x plus 2, which is repeated twice. And we know that we have to use the FOIL method. And after successfully using the FOIL method, we get x squared plus 4x, and then we say plus 4. Then we take this 2x plus 4 to the right-hand side. It becomes, oh well, the 2x becomes positive, and the 4 becomes negative, all right? I want you to check how I'm going to write it. This x squared, I'm just going to say whatever that I'm going to write here is supposed to be on the right-hand side. But then since I'll be having 0 on the left, do you see what I'm doing? I'm just taking what is supposed to be on the right and writing it here. And this 0, I'm going to write it there. Yes, I'm avoiding that extra step, which I did in the first problem. Do you still remember it? Of course you do. Now the 2x will become positive. It adds up to the 4x, so I get a 6x. Well, the 4 once again becomes negative, so the 4's will cancel out. I simply get a 0 for that. And this entire thing is equal to 0. And x is the highest common factor. And when I take it out, I'm just going to be left with this. And using my zero factor law, I find that x equals 0 or x equals -6. Well then, we have to take these two values of x and substitute them into the original expression and see which one actually works and which one do we have to cancel out. So, well, let's see which one is supposed to go. Well, if we take 0, -2 times 0 is 0, 0 plus 4, that is simply going to give me 4. The square root of 4 is 2. Substitute your 0 there. Well, you simply get 0. So you have 2 minus 0, which is 2. And this is equal to 2 on the right. So x equals 0 is true. It works. What about -6? Well, -2 times -6, that's positive 12. And 12 plus 4 is 16. The square root of 16 is simply going to be 4. Then you say 4 minus, you substitute an x value of 2 there. In fact, -6, I mean, sorry. So you simply get a positive 10. No, 10 is not equal to 2. So you simply cancel this one of -6. But just to confirm, I don't really trust my head. So let's go to the calculator and see if what I'm telling you is the truth. Yes, what I'm saying to you is 200% correct. So now we have to cancel out this -6. Now we said isolating the root has a mark. Okay, I think I wrote this in an ugly way, ne? Of course I did. We should have added another step of squaring on both sides. So what is the first step? The first step is to take this x to the right, and then we get x plus 2, okay? Then after saying that, we write another step in which we square on both sides. Then that step as well is going to have a mark. Then you're going to get a mark for writing this in standard form, for factorization, and for the answer with selection. Yes, it's normally 1 mark for that answer with the selection. So, yes. So we have 2 more problems for today's lesson. Let's quickly destroy them without showing any signs of mercy. Why should we be merciful towards mathematics? We've got to destroy it. So, well, let's say they ask you to please solve for x in this case. You are given the square root of x minus 2, which is added to 3, and this entire thing is set equal to 10, which is divided by the square root of x minus 2. All right? That's fine. So, well, the first thing that we see here is we have the square root of x minus 2. We also have the square root of x minus 2. That's fine. But the most important of the important things is the fact that now we are dealing with an equation that involves fractions. And we really hate fractions. We don't really like working with fractions. So the best way to destroy this is by multiplying throughout with the LCD, right? And the question is, what is our LCD in this case? Well, it's the square root of x minus 2. So what? we take the square root of x minus 2, we multiply it with the square root of x minus 2. In other words, the first term. We take 3, we multiply it with the square root of x minus 2. And then we take the right-hand side as well, which is 10 over square root x minus 2. And similarly, we multiply it with the LCD, which is the square root of x minus 2. All right? Then this one and that one will cancel out. Yes. So on the right-hand side, we are now left with a solid 10. But I want you to see on the left-hand side, we have the square root of this times the square root of that, which if you prefer, you can actually write it as the square root of x minus 2, which is all squared. And here you can see that the square root and the square will cancel out. So now you have x minus 2 here plus 3 times the square root of x minus 2. And this is equal to 10. All right? Okay, fine. But now you still have the root. Do you see that? So then what is it you should do? You need to isolate the root by taking x minus 2 to the right-hand side. So then on the left-hand side, we have 3 times the square root of x minus 2. What about on the right? Well, on the right, we have the 2 becomes positive, so we get a 12, and the x becomes negative, all right? Then after isolating like this, let's add another step of squaring on both sides. Yes. So now we square on both sides. And I want you to realize that the square belongs to 3 as much as it belongs to the square root of x minus 2. In other words, we'll say 3 squared, we get a 9. And the square root of x minus 2 squared, well, it's x minus 2. Then here we use the FOIL method. And after successfully using the FOIL method, we get 144 minus 24x. And here we get a positive x squared. Then we want to collect the like terms. Or maybe before that, we can distribute this one. So when we distribute that, we simply get 9x. And then we say minus 6. Yes? Yes, it was actually 9 into x minus 2. Oh, was it? So where does this 6 come from? I hope you have learned the most important thing. As girls will tell you that you don't jump high like Puma, no? But you take it step by step like Adidas. So I just decided to jump high like Puma, and I died as a result because now I have a 6, and it's not supposed to be a 6. It's supposed to be 18. So you're not really foolish when you write things step by step. There's a great deal of wisdom in doing things step by step. I really hope you have learned this lesson from your tutor because I just died, so please avoid that mistake, right? Yes, it's supposed to be 9x minus 18. And now if we take this 9x minus 18 to the right-hand side, it becomes negative. So when we say negative 24 minus 9, well, you simply get negative 33x. And when you say 144 plus 18, well, you simply get 162. And everything is equal to 0. All right. So now it's time for us to factorize. So what are we looking for here? We are actually looking for factors of 162 such that if we add them or subtract them, we simply get 33. So what are those factors? Well, if you are struggling to find them, you can really use the quadratic formula. That is perfectly fine. But then if you go to your calculator, it gives you 2 times 3 to the power 4. Okay. And 3 to the power 4 is 81. No, I think to avoid struggling, let's just go to the quadratic formula. It saves a lot of time and a lot of stress. So you benefit twice. Not bad. Well, I get x equals 27 as the first solution. And the second solution is x equals 6. And indeed, 27 plus 6 is 33. But then I personally, I don't like using the quadratic formula. So even after using it to help me with the solutions, I'm simply going to write those solutions as if I knew the factors. Do you see that? Of course you do. Then I can now say, well, x equals 6 or x equals 27. And remember, you have to check your solutions so that you can be 100% sure which one is correct and which one is not. So now we go to the original equation and we want to substitute 6. So well, 6 minus 2, that's 4. And 4 plus 3, in fact, that is 4 years. The square root of 4 is simply 2. And 2 plus 3, that is 5 on the left-hand side. Now, 6 minus 2, that is 4. The square root of 4 is 2. 10 divided by 2 is 5. Yes, x equals 6 works. What about x equals 27? 27 minus 2, that's 25. Square root of 25, that's 5. And 5 plus 3, that is 8. Well, once again, we have 25. The square root of 25, it's 5. And 10 divided by 5 is 2. So no, x cannot be 27. So respectfully, you go to 27 and you cancel it out. All right? Yes. So the question is, in a case like this one, where you had to find the LCD, where will the marks actually be? Well, that's a very good question. Well, let's quickly give it a good look and see where the marks are normally at for a situation like this. And how much would it be worth anyway? Well, it's actually for 5 marks. And if you did it like this one, then you're going to get a mark for isolating, for simplifying up until the stage of isolating. So you don't really get a mark for finding the LCD, but that's perfectly fine. But you never know. In maths, there's a nice instruction that says, show all your workings. You never know. What if the examiner wakes up one day and says, no, I'm going to give a mark for the LCD and not for isolating the root. So better safe than sorry. And of course, squaring on both sides always has a mark for writing this in standard form, for factorizing, and then for your solutions with selection, of course. Yes. But I know that you wanted to do it in a much easier way. And indeed, there is an easier way, which is called the case substitution method. Yeah, it's the one that you learned in grade 11 when you did exponential equations, as well as equations involving rational exponents. So let's quickly show you how it would work in this case. Now the question is, when do we use the case substitution method anyway? Well, firstly, before I give you the answer of when do we use it, I want to give you the reason why we use it in the first place. The whole point is to simplify the equation that we are given, or an expression. But simplicity is the whole point for a case substitution. So here we can see that we have two root signs on both sides. So we want to simplify this. So well, here we are going to allow k to be the square root of x minus 2, which means that every time I see this, I now see k, and I have a 3 there, and I have 10 over k. Who wouldn't want to work with the second equation as opposed to the first? Do you see that? Right. Then, of course, our LCD is going to be k, and we multiply every term here by k, as we did with the square root of x minus 2 previously, of course. So then, when we multiply k by k, we get k squared. When we multiply k by 3, we get a 3k. And on the right-hand side, we get a 10, because multiplying this by that, the k's will cancel out. But then right away, I want to write this in standard form because I can see that it's a quadratic equation. So I'm going to take my 10 to the left and it becomes negative. Then I can now factorize my quadratic equation by saying, oh, well, these are the factors. Factors of 10 that add up to 3. The bigger number takes the sign of the bigger one. What am I saying? I want to say the bigger number takes the sign of the middle term. Right, that's what I wanted to say. Sorry about that. Then now we can say, well, k equals negative 5 or k equals 2. But what is k? Well, k is actually the square root of x minus 2, right? And this is equal to negative 5. Or k, which is the square root of x minus 2, is equal to 2. But then once again, or rather not really once again, what is wrong with me? I want to say immediately, you realize that this is a red flag. Why? Because anything that goes or rather comes out of the square root must be positive. So you can never have the square root of something which is equal to a negative number. No way. Whatever goes into the root must come out positive. Yeah, not in a cube root, in a square root, in a fourth root, in a sixth root, and so forth. Every time when n is even, then it must be positive. So now we can forget that part and continue solving this one. So we come here and we square on both sides. Preferably add another step before squaring on both sides, all right? And then you can now have your x minus 2, which is equal to 4. This would mean that x equals positive 6, which is the same 6 that we got when we did it for the first time. Do you see that? Of course it is. So, yes. Yeah, I think the case substitution method proved to be the easiest way Well, you can't really say easiest, degrees of comparison, because we only did it in two methods. So every time you're comparing two things, the best you can say is better. So the case substitution method was better than the first approach that we used. Hey, grammar is very important, ne? Yes. That's why you had to learn it in school. Oh, you're still in school. So I'm really hoping that you're speaking better English compared to me. Yes. And this thing of people who know maths don't know English or things like that, that's a lie, guys. You really have to make sure that you know English. You'll be in university soon enough, and trust me, you want to know English. I remember when I arrived in my first year, I had to think about what I'm going to say. Like, think of it. I have to think about how am I going to greet the person that I'm going to go to. Say that is a white person. How am I going to greet and how am I going to keep the conversation going? Imagine, because I wasn't really fluent, if we can say, in English. So it's very important that you practice your English so that you won't have to think hard about what are you going to say when you get there. Imagine. So it's very important. It's a language after all. So you really have to invest in your English. I'm not just giving you mathematical tips. I'm giving you life tips as well. I just realized something. I didn't show you where the marks are if you are doing it by means of the case substitution method. Yes, I think it's rather important that you know where the marks are. So let's quickly reverse everything and then I can show you the mark allocation. All right, now we have now shown everything. So this is what you're going to say, all right? For writing this equation in standard form, you get a mark. For factorizing this equation, you get a mark. For these two values of k equals -5 or k equals 2, that is another mark. And for selecting, actually, yes, for the selection, by saying this thing is not equal to that and therefore choosing this. For choosing that, you get a mark. That's a bad tick. It's like I'm not a teacher. Yeah, this one is much better. Right. And then after that, then it's a mark for the final one. Yes. So you really need to know where the marks are. Why? Why do you need to know? So that you can, if possible, eliminate unnecessary steps. Yes. For instance, when you are solving for x in a quadratic formula, or at a quadratic equation by using the quadratic formula, you don't have to show the step of simplifying your quadratic formula because there is no mark for that. Do you see that? So it's very important. It helps you to save time as well in the exam. Well, we have one more problem to consider. So let's quickly destroy it and we can gladly go home. I know that learners really enjoy it when the lesson is over. When the bell rings at school, that's the most favorite time of day. Yes, I used to love that time myself. When I hear the siren ringing, I know that it's time. It's time. And if the teacher is still speaking, no, you're not listening anymore. You now want to go home. You're packing your bags. So then how do you solve for x in this case? Well, here we can see that we have two different roots. So we can't really use the case substitution method. Do you see that? No? We have the square root of x plus 4, the square root of x minus 2. They're completely different. And even if you were to multiply both sides, not really both sides, but throughout by the LCD, which is that, well, it's not really going to help you that much. So what is the best thing to do? It is to take this entire fraction to the right-hand side because you can now get to square on both sides. Well, now you have the square root of x plus 4 on the left, which is set equal to 4 divided by x minus 2. Of course, inside of the square root. Then after saying this, you now have to square on both sides. Please add that part. Do it on another step. All right? Yes, here I'm doing 2 steps in 1 step, but please add an extra step for that. Yes, I would really appreciate it if you did that. And then where to from this point? Well, the square root and the square will cancel out. So now you have x plus 4. Now here you square both the numerator and denominator. So you say, well, 4 squared is going to give you 16. And the square root of x minus 2 squared, you get x minus 2. Then you multiply by the LCD, which is x minus 2. So you have x minus 2 times x plus 4. And on the right-hand side, well, you simply have 16. But of course, if you so prefer, you can show that you multiply this entire thing by 16. That's still fine. In fact, let's show it. Not really by 16, but by x minus 2. But if you do this, then it's always nice to put that one in brackets. And then on this one on the left, you just need to use the FOIL method. So take this one, take that one, and do the same for the others as well. Just to show it for once, x by x, we get x squared, and then x by 4, that is 4x. Negative 2 by x, negative 2x, negative 2 by 4, negative 8. The x minus 2's will cancel out, and this is what you have. Then it's time for you to write this in standard form. 4 minus 2, that is 2. And then you have negative 8 minus 16. But it's the same as 8 plus 16, which is negative 24. And this is equal to 0. You have a quadratic equation. You need to factorize it. What are factors of 24 that add up to 2? Well, 12 times 2, they are not enough. 6 by 4, yes. Those are the 2 factors that we need. The bigger number takes the sign of the middle term, and this is what we have. So this means x equals negative 6 or x equals positive 4. And we don't really accept that both of them are correct, but then sometimes they may be both correct. But it's very wise for you to test your solutions. Now, negative 6 plus 4, it's going to be negative 2. And the square root of negative 2, it's not going to work. So right away, you cancel out your negative 6. Because remember, you always substitute into the original equation. Very important. Now, what about 4? Well, if we talk about 4, then we have 4 plus 4, which is 8. And here we have 4 minus 2, which is 2. And 4 divided by 2 is 2. No? No, 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 no. No way. No way at all. No, no way at all. So let's see here. What could have been wrong? Let's quickly give it a good look. Give it a good look. What could have been wrong here? Hmm. What went wrong? Because we did everything as we should. We really did. Hmm. Did we FOIL this out correctly? X by x squared, yes. X by 4, positive 4x. Negative 2x, negative 8. That's true. And this is equal to 16. Okay. Then what? Yes, it's really 16 on the right-hand side. And then now we collect the like terms, the 16 will become negative, and indeed, negative 8 minus 16 is 24, yes. And 4x minus 2x, it's really going to give us positive 2x, okay? And factors of 24, yes, they should be like that. It's 6 and 4, that is true. And the bigger one, which is 6, takes the sign of the middle term, that's true. X equals negative 6 or x equals 4. That is supposed to be true. So why is it refusing to cooperate? Or am I the one who's simply not? I don't know who's simply not what, but maybe I'm the problem, you know? Mm. Okay. What about if we try to substitute it here? Well, negative 6 plus 4, that's negative 2. And then negative 6 minus 2, that's negative 8. And 16 divided by negative 8, that's negative 2. So if we substitute here, then our negative 6 works. What about 4? Well, 4 plus 4, that's 8. 4 minus 2, that's 2. 16 divided by 2, that is going to be 8. So even 4 will work if we substitute it there. Do you see that? Okay, so it means for this one, we didn't really have to substitute it at in the original equation that was given to us. Yes, yes. But in most cases, we substitute into the original equation that is given to us. But if this is not possible, then maybe we can check in the steps that follow in the steps that follow and be glad. Yes, we can really test in the steps that follow and be glad. No, I can't really find a reason why we are wrong. So, no, no, this one was a special case. We checked our solution by not really by substituting into the original, but yes, no. So it means both of them actually work, all right? Yes, both of them are true. And once again, for squaring on both sides, that is a mark. For writing this in standard form, that is a mark. And for factorizing and for stating your solutions. Yes. So here there was no selection. Maybe you can get 2 marks for those solutions, or maybe they can give you a mark perhaps for, maybe for taking this one on the right-hand side. Well, it will really depend. But the steps that we are sure that dark or light, green or blue, whatever, they have marks. It's those ones that we have given the marks there. Yes, no, I have really verified everything. So this one was really a special case. Please be aware of this. There are certain situations whereby it won't be possible for you to substitute into the original equation, but then try to go to the equation that you have simplified, all right? The one that doesn't have a root sign anymore. Or even here, you can just go to your standard form, but of course, on your standard form, it's going to work. So, yes, 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 yes. Please really, really check that. So thank you so much for watching this lesson through to the end. I really and strongly believe that you should be able to solve for x in root equations now. So please don't forget to subscribe. No man, thank you so much, guys. Over and out.